Question 3 wants us to integrate trigonometric functions. And to do this, we need to remember our trigonometric identities. So each one of question 3 has a slightly different way of doing it. I won't be able to go through all of them, but I hope I'll be able to go through some of the key ones for you. So we'll start with question 3a. 3a asks us to integrate 2 sine squared x over 3 with respect to x. Now the problem here is that it's very difficult to integrate sine squared on its own. It's easy if you have a cosine beside it, as we saw in in question 1, but when it's on its own it's a little bit more difficult. So what do? Well, we actually have to make use of a formula. So you guys remember this one, where cosine 2 theta is equal to, and there's actually 3 things it's equal to, but the key one we're going to use here is 1 minus 2 sine squared theta, right? So in this case, I've got my 2 sine squared theta. I'm just going to move the 1, or rather this over and then this back. So what do I get? I get, this is the same thing as the integral of 1 minus cosine of 2x over 3. And you see, what I've done here is I've removed any power on my trigonometric function. Instead, I'm dealing with it just as a simple trigonometric function, which I can integrate, which I know how to integrate on its own. So if I integrate this with respect to x, what do I get? Well, I get integrate 1, I get x minus, now what does cosine integrate to? Well, I differentiate sine to get cosine, so I integrate cosine to get sine of 2x over 3. But of course 2x over 3 has to be taken into account. That usually would have come out during a differentiation. So I need to multiply 3 over 2 to that in order to make it disappear when I differentiate. And of course, as with any integration, I have a plus c. So what does that leave me with? That leaves me with x minus 3 sine 2x over 3 all over 2 plus my constant of integration.